So next topic is ionic equilibrium in solution. So the substances, the solution which conduct electricity are called as electrolytes. Okay. Now here the conduction is due to the ions. More the number of the ions, more will be the conduction, and we will call that to be a good electrolyte. So here I am going to introduce you the concept of the electrolyte. There is something called as electrolyte and there is something called as non-electrolyte. Electrolytes are the one which is capable of conducting electricity, and non-electrolytes are very simple. They doesn't conduct electricity because they don't have ions. So our interest is electrolytes, means which conducts electricity. So electrolytes are, one is strong electrolyte and other is weak electrolyte. What does this mean? Strong electrolyte, I will say that there is maximum ionization. There is maximum ionization or a complete ionization of that molecule. Here, less ionization. Means if I give you an example that NaCl, and if I put this into water, what I am going to get is Na plus and the Cl minus. This is how it is going to split. Means if I take 100 molecule, for simplicity I am considering that there are 100 molecules of NaCl. Now if I put this into water, out of 100, 95 molecules will split. Means I will get 95 Na plus and 95 Cl minus, remaining 5. Or I can take 99, let's take maximum ionization. No? 99 will split, 99 molecule out of 100 is going to split as a Na plus and a Cl minus. And one molecule is going to stay as a NaCl only. But here maximum ionization is there and the backward equilibrium is very less. Backward equilibrium is very less. Backward reaction. So this is just a forward reaction. There is just a formation of Na plus and the Cl minus. Right? So here there won't be any equilibrium, just a forward reaction. Now if I take a weak electrolyte like a acetic acid, if I am taking CH3COOH, if I put this into water, this is a weak electrolyte and here there is a less ionization. Less ionization means what? Out of 100, there are 100 molecules of CH3COOH, then out of 100, just 95 may split. 95 may split means what? You may get a acetate ion, CH3COO minus 95 and H plus 95, and remaining 5 will remain as a acetic acid. Now there is an equilibrium established between this because there are many molecules of acetic acid which is remaining unionized. Means what is happening? 95 equilibrium, again I will explain you over here. Equilibrium means this 9, like you are getting just 5 and 5. If I made a mistake in explaining this, out of 100, just 5 molecules split as a CH3COO minus, that is acetate, and 5 will split H plus. Means out of 100, 5 acetic acid molecules, CH3COH molecule are splitting as this. Remaining 90 are remaining as a acetic acid only. Now what will happen? At equilibrium, rate of forward reaction is equal to rate of backward reaction. This is an equilibrium. At equilibrium, 5 molecules of acetate and 5 atoms of hydrogen, 5 atoms, ions of hydrogen will combine to give you back acetic acid. At the same time, 5 molecules from those 95 will split to give you acetate and the H plus. Means it is not that this is first combining and then there is a splitting backward reaction. No, this is equilibrium. Both the processes, combination of this and the splitting of 5 molecule takes place simultaneously. Means at equilibrium, concentration of acetate, means if you check at any time, you will find that there are 5 acetate molecule and 5 H plus and 95 acetic acid at equilibrium, right? So this is what is the meaning of weak electrolyte. So weak electrolyte shows equilibrium reaction because there is no complete ionization. So next topic is ionization of weak electrolyte and Oswald's dilution law. Means if you take a weak electrolyte, I'll just summarize over here that if you take a weak electrolyte of, let's say, acetic acid CH3COH and put this into water, what you are going to get is that this type of equilibrium will be set CH3COO minus and the H3O plus, means H plus, whatever H plus will be there, it will be reacting with water and you are going to get this type of equilibrium. So equilibrium constant in terms of concentration will be written as this way. So concentration of the H3O plus divided into concentration of CH3COO minus divided by concentration of CH3COOH and the concentration of water. Now what I do, I take this concentration over here, concentration into K into concentration of water over here, and what I write is this H3O plus CH3COO minus divided by CH3COOH. This is acetic acid. Now this is constant, and water concentration, the square brackets represents a concentration. Water concentration is also going to remain almost constant. See, it is a weak electrolyte. Weak electrolyte means how much of it can get dissolved in water. Like if there is 1 liter of water and you are putting just 1 milligram, 1 liter of water is there and you are putting 1 gram of acetic acid into it. So out of 1 gram, 1 milligram is going to get dissolved in water. Very less amount of that is going to get splitted up, means very less amount of the acetic acid is going to form H3O plus, means very less amount of the like out of 1000 molecules, I'm just taking an example of 1000 molecules, maybe 10,000 molecules of H2O, just 1 or 2 are going to get converted to H3O plus. So what I can consider is concentration of water to be constant. So this constant and this constant is, I will write this is called as Ka. This is a dissociation constant of a weak acid, right? This is a weak acid. So what remains is H3O plus and CH3COO minus. This is CH3COOH. Oswald's dilution law. Coming to the Oswald's dilution, what it says is that the degree of ionization is directly proportional to the dilution. More the dilution you make, more the dissociation of the weak electrolyte is going to take place. Means more number of the ions are going to dissociate. Or other term we can say is that degree of ionization is inversely proportional to the concentration. More is the concentration, less is the degree of ionization. So let us go, let us prove that over here. Let us prove that over here. Let's take this. There is a AB, which is aqueous, means it is in the water. You are going to get A plus aqueous and the B minus aqueous. Now at time t is equal to 0, at time t is equal to 0 means the dissociation process is not started. So what it will be? It will be just C over here. I will be writing this to be C to be some concentration. It is having some concentration, and at time t is equal to 0, what are this concentration? The dissociation is not yet started. This will be 0, right? Now at equilibrium, what I am writing is C minus C alpha. Now I have introduced this alpha term, right? And here I will write C alpha and the C alpha. This C alpha and C alpha together represents the, C and alpha represents the concentration. Like how much amount of the ions are getting dissociated. Alpha is the degree of ionization. Alpha is degree of ionization, means alpha is given as number of moles or you can take number of molecules getting dissociated, number of moles I will write, number of moles getting dissociated, right? Number of moles tells about the number of molecules also, like 1 mole 6.02 half mole, half of that, right? Number of moles getting dissociated upon total number of moles of molecules. Let's say alpha is just a ratio, it doesn't have any unit. Alpha is just a ratio, like alpha, let's say there are moles, saying moles, I will use the word, I will just use the number, like there are 100 molecules of acetic acid or 100 molecules of AB. Out of 100, just 10 are splitting as A plus and a B minus. So I will write that number of moles or the number of moles getting dissociated. Out of 100, 10 are getting dissociated. Divided by total was how much? 100. So alpha is what? Therefore alpha is 0.1. Right? If out of 100 just 5 are getting dissociated, then it is what? Therefore alpha will be 0.05. Isn't it? So what could be the maximum value of alpha? You can think over this, pause for this some time and just think of maximum value of alpha. See, if there are 100 molecules, then maximum value can be of alpha. Alpha could be have maximum value of 1. This is maximum value, and this is true for a strong electrolyte. This alpha tends to 1 for the strong electrolyte because maximum ionization takes place. Let's say there is a total number of 100 molecules and all 100 are getting dissociated. So 100 by 100 will be alpha. So alpha is equal to 1 is true only for the strong electrolyte and not for the weak electrolyte. So here just imagine that I have written C minus C alpha. If it was a strong electrolyte, means at equilibrium, just imagine that it is a strong electrolyte. Alpha for strong electrolyte is almost is equal to 1. Strong electrolyte means what? Alpha will be 1, right? So C minus C will become what? 0. So at equilibrium this is almost 0 and this will be C alpha into C alpha. Means this will be C and this will be C. Right? So for simplicity, alpha is not 1. So that's why I am writing C as C alpha, and here alpha is the degree of ionization. So if I want to write the equilibrium constant or a dissociation constant of a weak acid, K is a dissociation constant of the weak acid. That is what I derived first. So for this, concentration of the A plus into concentration of the B minus divided by concentration of AB. Therefore, Ka will be is equal to what? C alpha multiplied by C alpha divided by, I can take, okay, I'll write here as a C into C alpha. Therefore, Ka will be is equal to C alpha square upon C into, sorry, C square alpha square. I am taking C common, so 1 minus alpha. Therefore, Ka will be is equal to 1 of the C will get cancelled. C alpha square 1 minus alpha. Right? So for the weak electrolyte, dissociation is very less. Right? Means out of 100, let's say just one molecule is dissociating, then alpha will be what? 1 divided by 100, that is 0.001. So 1 minus 0.001, just giving an example, will be approximately equal to 1. For weak electrolyte, 1 minus alpha is approximately is equal to 1. Right? So what I'll do is I will substitute over here. So there is a less space. Write it here. So therefore K will be is equal to C alpha square upon 1, because 1 minus alpha is approximately is equal to 1. So therefore alpha square is equal to Ka by C. So therefore alpha is equal to square root of Ka by C. What does this say? That alpha, the dissociation, degree of ionization or the dissociation is inverse. This is constant. I can generalize this way. Therefore, alpha is directly proportional. Just see that. This is alpha and this is directly proportional sign. Okay. Alpha is directly proportional to the square root of 1 by C because K is alpha. Sorry. Inversely proportional to the square root of C. I can write this way because K is a constant over there. If you put that proportionality sign, you will introduce K. So what it says that degree of ionization, how the weak electrolyte is going to get dissociate, is inversely proportional to the square root of concentration. Means the concentration is more, then dissociation will be less. If you dilute it, if you add more amount of the water, it will become dilute. So dilution increases more splitting. Okay, so that is what it means. What is the meaning? In short, what it says is that if there is acetic acid, this way, acetic acid, CH3COOH, and there is certain amount of the water and it will get splitted up as CH3COO minus and H plus will combine with water, so I will write this to be H3O plus. So it's certain concentration. You are getting 5 molecule, like let's say this is 100 and this is 5 and 5. This equilibrium is set over here. Now what you do, you add more amount of the water. If you add more amount of water out of 100, this will be 10 and this will be 10, and means the splitting will take place more if you add the dilution, if you add more water. So that is what is the Oswald dilution law says. The ionization, the degree of ionization depends upon the dilution. More is the dilution, more is the dissociation.